Diesel engines. A diesel engine, also known as a compression ignition engine, is an internal combustion engine that uses the heat of compression to initiate ignition to burn the fuel that has been injected into the combustion chamber. This is in contrast to spark ignition engines such as a petrol engine, gasoline engine or gas engine using a gaseous fuel as opposed to gasoline, which uses a spark plug to ignite an air-fuel mixture. The diesel engine was developed by German inventor Rudolf Diesel in 1893. It has the highest thermal efficiency of any regular internal or external combustion engine due to its very high compression ratio. Low-speed diesel engines, as used in ships and other applications where overall engine weight is relatively unimportant, can have a thermal efficiency that exceeds 50%. The diesel internal combustion engine differs from the gasoline-powered Otto cycle by using highly compressed hot air to ignite the fuel rather than using a spark plug, compression ignition rather than spark ignition. In the true diesel engine, only air is initially introduced into the combustion chamber. The air is then compressed with a compression ratio typically between 15:1 and 22:1, resulting in 40 bar or 580 psi of pressure compared to 8 to 14 bar or 200 psi in the petrol engine. To put this into relation and context, we pump our tyres up to sort of 20 or 30, 35 psi. This high compression heats the air up to 550 degrees Celsius. At about the top of the compression stroke, fuel is injected directly into the compressed air in the combustion chamber. This may be into a gap in the top of the piston or a pre-chamber depending upon the design of the engine. The fuel injector ensures that fuel is broken down into small droplets and the fuel is distributed evenly. The heat of the compressed air vaporizes fuel from the surface of the droplets. The vapor is then ignited by the heat from the compressed air in the combustion chamber. The droplets continue to vaporize from their surfaces and burn, getting smaller until all the fuel in the droplets has been burnt. The start of vaporization causes a delay period during ignition and the characteristic diesel knocking sound as the vapor reaches ignition temperature and causes an abrupt increase in pressure above the piston. The rapid expansion of combustion gases then drives the piston downwards, supplying power to the crankshaft. A diesel engine with no turbocharger will produce less power output of the same swept volume than a petrol engine. Here's the volume diagram for the ideal diesel engine. Numbers 1 to 4 in a clockwise direction. Combustion occurs at almost constant pressure and the exhaust occurs at constant volume. The work that is generated for each cycle corresponds to the area within the loop. Common rail system. In common rail systems, the separate pulsing high pressure fuel line to each cylinder's injector is replaced by a high pressure pump which pressurizes fuel up to 2,500 bar, 36,000 psi in a common rail. The common rail is a tube that supplies each computer-controlled injector containing a precision-matched nozzle and a plunger driven by a solenoid or piezoelectric actuator. Cold weather starting. In cold weather, high-speed diesel engines can be difficult to start because of the mass of the cylinder block and cylinder head absorb the heat of compression, preventing ignition due to the higher surface to volume ratio. Pre-chambered engines make use of small electric heaters inside the pre-chambers called glow plugs, while the direct injected engines have these glow plugs in the combustion chamber. Waxing, gelling. Diesel fuel is also prone to waxing or gelling in cold weather. Both are terms for the solidification of diesel oil into a partially crystalline state. The crystals build up in the fuel line, especially in fuel filters, eventually starving the engine of fuel and causing it to stop running. Low output electric heaters in fuel tanks and around fuel lines are used to solve this problem. Also, most engines have a spill return system by which any excess fuel from the injector pump and injectors is returned to the fuel tank. Once the engine is warmed, returning warm fuel prevents waxing in the tank.